start my talk with this imagery, and it's one of my favorite imagery. It's an imagery that no animal in the history of the entire planet has ever seen. It's what I call the first light. The first light happened 540 million years ago. That was the first moment simple animals in the ocean developed the first photosensitive cells in the head of the animal body at the first glimpse of what the outside world was like. Since then, more than 500 million years ago, the evolution of visual intelligence began. But more than that, the evolution of seeing, developing eyes, developing visual intelligence is deeply, deeply intertwined with the evolution of intelligence as a whole. We wouldn't be where we are. We wouldn't be the most intricate animals of the universe we know if it's not thanks to the ability to see and to perceive. In fact, human development began with seeing and sensing the world long before we're able to utter the first word.
Hello everyone, welcome to your channel AI Fun Fact for All. For those of you who are new to this channel, my name is Pedro Mogan. I have a PhD in computer science, and in this channel we talk about AI and machine learning and how we can use it in our everyday life. In this video, we are going to talk about a specific topic which happens recently, the NeurIPS workshop. So NeurIPS is actually one of the most prominent conference in AI and machine learning that lots of people from academy and industry actually join in this workshop and conference, and they try to provide the edge of the technology. So as I mentioned, NeurIPS is a leading conference in AI and machine learning, and lots of people from academy and industry come and join and try to showcase what they have been working on. And this is very important in the realm of having open source technology so that everybody can access to it and we can actually progress more and more the information and the knowledge so then we can actually get to the best cases faster because history has shown that having a community-driven technology will actually provide the best result. So it is not very hidden from anybody that autonomous driving is actually getting a lot of attention. So you see it from Tesla and so many other companies like Waymo from Google. And it is also not a thing that we can see in NeurIPS. The first keynote speaking for the NeurIPS was for autonomous driving. So that's why the first topic and category that I have considered is also autonomous driving. So we have the, very quickly talking about it, we have the perception that you do prediction and planning, and after that you basically do control. So they mentioned that they are using bird's eye view in order to basically improve their basically generalizability, but it requires a labeling. And they have talked about a SwiGLU former. So these are things that I just give you some keywords. So later on you can basically go and walk over them. Obviously we cannot go over everything in this video. And then they talk about, so these are the people from Waymo, Google. And then they talk about driving as a conversation. So they consider trajectory as a sentence which have both local continuity and global context. So they introduce the motion element. And then they also talk about the comparison between RL and imitation learning. Basically, they mentioned that when we're having a counterfactual, which is basically lots of different adversarial situations, we don't see them in a supervised or imitation learning. So that's why it's required to have RL for a reliable and resistant autonomous driving. And here's also a very nice figure. So the number of demos you can see on the y-axis, and then the number of tasks. So as the number of tasks or the frequency of them actually increase, that's where the rewards become more effective. Otherwise, in the very beginning, you can just use demonstration or basic imitation learning. And there is one paper. So for each of these categories, I will also provide a few papers that you can take a look. Non-reactive autonomous vehicle simulation. So without diving deeper, let's go into the second category. So for second category, we have data and evaluation for foundational model. So we already know that basically this language model was the reason that we have seen lots of attention for the ML and basically AI. So it is also no surprise that we see lots of paper, lots of spotlights on this foundational model. The main part that I want to consider in this category is data and evaluation. So the thing is that scale and quality, data acquisition and transformation, experiment rather than intuition are basically the different stage for considering a data for a pre-training task. And then they mentioned that use RMSNorm, use QK norm, and change the order of the layer norm. Then we have simulated annealing. So this is a very famous approach for handling basically the learning rate. You basically try to upsample very high quality data, and then you try to lower your learning rate. So in the very first 10 billion tokens, what you do is that you try to start from zero. You try to go off, which is considered as conventional warming up, and then after that you on the realm of trillions of tokens. So you try to, in a cosine manner, you try to reduce your learning rate, or basically cooling down, and then at the end, like 50 billion, you try to actually linearly reduce it. Otherwise, you will basically experience a catastrophic forgetting. There are a few papers that I want to also talk about that you can basically take a look on your own. We have RepliQA, so it's a question answering dataset for benchmarking element on unseen reference content. This is one paper. SureMap simulated mean estimation for single task and multi-task disaggregated evaluation. Benchmarking large language models for task agnostic. Stronger than you think, benchmarking weak supervision on realistic tasks. Shopping MLU, a massive multitask online shopping benchmark for large language model, and DMCVB, a benchmark for representation layering for continuum with visual distinction. So you see lots of these papers are trying to provide a benchmark, and then it's also interesting to see that these benchmarks are actually trying to show that the open source models out in the wild are actually couldn't provide a good result. So for those papers, it is important to see low ranks for this, and then they provide to basically create this benchmark either for evaluation or even training, or actually try to provide some solution on how they consider a good way of basically training them would be. Number 3 has to be to the transformer architecture. We have so many different architecture, but transformer is the backbone of basically large language models. So that's why I think it's very important to consider them as our third category. We have different categories in here. We have almost for 7B, which has the conventional multi-head attention. Then we go to the Lamma 3 categories like 8B, which has the group query, which basically try to somehow have an sparse in the cube and values. So basically the queries are grouped, and then try to go and have the similar keys. And then we have Falcon, which is basically multi-query. All of them has one query. So basically there is one paper which has talked about the multi-head attention. You need at least 2 to basically see the different nuances of your language and see the different positions of which words are actually attended to each other from a different understanding or different concepts of language model. So one head is not enough. Then we have SwiGLU. So this is a new basically activation function which basically combine the swish activation, which improve the ReLU, providing a smooth transition around 0 and help optimization, and with the glue, which is an effective tool for capturing long dependency while avoiding vanishing gradient metric. So transformers a low rank representation of kernel for fast attention, and it is also important why we need to warm up the learning rate. So this is actually very important. Let's take a look at the mixed surface where this is also was a very important topic in the one, which basically kind of similar to a sparsity in here, but the fact is that each token will actually be ignited by one of these basically experts in here, and then we have a router which decide that which of these experts need to be considered. And here are a list of the different papers. I'm not gonna go over all of them. As I mentioned, I put the link, but these are also not all of the papers. I try to look at the basically the papers that have, for example, good industry or from a good institution. So these are the main ones which you can take a look at and try to get more information as well. We will get to some of the papers that I think are very important, and I actually got a chance to talk to the author of the paper. I will try to share a very quick overview of those as well. Now, number 4 has to go to the large language model itself. So this is by far the largest portion of the basically language model of the whole conference, and it includes the benchmarking. So benchmarking, we already have talked about it in the previous section, and then we have the pre-training, which basically we talk about what are the general strategy. So we talk about W, the sequence model. You consider 4096, then to go to 60 million batch. After that, 2.87 trillion token using cosine decay, and then 1.2 million steps. And then what you need to do data mixing and long context pre-training. So obviously the same idea as curriculum learning. You first start from something that are simpler, and then after that you will try to go to more complex topics such as math and long context results. And then annealing, obviously. So we have post-training in Lamma. So let's take a look at the architecture of post-training in Lamma. This is something that was actually presented by the people from Meta. So as mentioned, we have rejective sampling here, and then we have SFT data, and then we have the SFT model. They try to use a DPO. So there are also somebody like PPO. We'll talk about that. But direct optimization actually provide a faster result and require less number of fine-tuning of the parameters, and then they try to find the best model. Why is this important? Because I believe lots of people requires this fine-tuning stage and post-training and alignment rather than the pre-training. So it's very hard for lots of people to actually go to a stage. So you usually use a foundation model and try to fine-tune it for your specific stage. So that's why I think it's more important to know these things. So the stages of you start from the prompt and skill selection, you go to the supervised fine-tuning, then you have instruction fine-tuning, and then you have preference fine-tuning, and then finally RL and advanced tuning. Is this necessary? I would say in lots of cases RL wouldn't be necessary, but definitely if it is very special situation and you really want to tackle lots of different cases that you might not see, then probably RL would be a good option. And the supervised fine-tuning includes the data mixing and then curation. So curation means you create new data, very evaluation are behind. So kind of look at it as a perspective of an active learning. You want to find some situation or some data sets that creates low evaluation record for you, and then those are considered harder basically trajectory to learn. And then we have PPO. So PPO or proximal policy optimization consistently outperform the DPO, but with the cost of implementation complexity, memory usage, and throughput. So if these things are not important for you, then probably PPO definitely is better because it's definitely gonna outperform. And then we have also something about compute increase quickly, but data do not. So this is really important that we look at given the same data, we want to improve data efficiency. What are the approaches? We have RH01, which not all the tokens are what you want or what you need. This is basically one paper. And then we have MIM, mean in the middle, a new pre-training paradigm. Then we have token-based technique, which basically the exact and fine-grained unit in the learning, flexible, context-dependent, simulate how humans look at the data for understanding. Finally, they talk about selective language modeling. This is also very important because you will decide what sort of input or tokens you want your model to actually be trained on. So I think this is also a very important concept that you can take a look. There is lots of other papers specifically for this CCA. I'm not gonna go over all of it, but I definitely encourage you guys to look at this. There are a few that I want to specifically talk about them, which I got a chance to actually talk to these people. So if you go, and then I can share with you guys in here. So this paper is an online adaptation of language models with a memory of amortized context. So this is important because we want to adaptively update our model, but how we can do it in a way that is the most effective. So the whole idea is that instead of having, so let's say you have a context of documents, and then you consider an amortization network, and then you're gonna you have a question, and then you want to create an aggregation network, and then create this in addition to your database. So consider you want to do fine tuning, but among all of the way, you're considering prompt tuning, which basically you add something into your basically original weight, but then this weight, how you're gonna update it is basically through this basically aggregation network. So I think this is important because, as the author mentioned, when they are updating, you don't have to update through all of it. You basically can select some of these and try to consider like approximate basically back propagation, which requires we don't require all of your basically documents to be amortized. And why is that? Because some people might say, okay, I will just do basically based on the rank, which is not necessary to. There are so many cases that you have, for example, repetitive context in your rank, and the repetitive context doesn't necessarily provide all of the required answer to your question. And for that reason, if you just confine yourself with the top K, and obviously you have the limitation of your context window, this is not going to be enough, so you won't get a good result because you don't have factual result. However, the result that you want might be in, for example, number 11 or 12. So basically, not all the context documents should be ranked based on the basically concept of their relevance. So that's basically the main idea. I found it very interesting. Trying to find a good basic figure that I can find. Unfortunately, I couldn't find anything. But the whole idea, this is exactly also similar to the previous one. We're trying to focus on the retrieval, and then instead of basically you try to retrieve information based on the relevance, you try to first train a basically proxy model which try to learn reverse of the language. So for example, instead of training to learn the next token based on the previous token, you try to basically learn the reverse of it. And then what will happen, you try to give it an answer and try to retrieve what was the question. And if you do that, then by comparing the question that each of these retrieval will respond, you have a better understanding. Basically, the whole idea is that, okay, I have these documents now. Each of these documents, I try to answer to what question, and then I rank it based on that. So I think this is actually a very clever idea, and there's lots of benefits to it. For example, it can help against the jailbreak, which basically if somebody tried to do some hacking inside the prompt that your basically red teaming or your shield couldn't detect it, if you try to generate a question based on that, then the question doesn't necessarily follow that pattern, and for that reason it is easier to detect the jailbreak given the question of what's your retrieval. So I think this was also a very good paper to consider. And going on to the last one that I want to talk about is a small to large. This is also a very interesting paper, similar to the basic idea of you want to do a scalable data selection. So obviously you have fine-tuning, but you don't have access to all of the data. You don't want to get all of the data at once. So what you want to do, you want to be selective on what data you want to basically give to your model. And I think this is very important to consider. If you can find another image for this one, this is very hard that these people don't provide a nice figure, but basically the idea of this one is that basically after talking to the people from basically the author, they mentioned that what we need to do in this situation is that they try to create a trajectory of the loss, and then when you create the trajectory of the loss, you basically can cluster them. And how you can save the trajectory of loss is just you basically try to save basically the checkpoint. You save basically the error that they have, and then the trajectory of them, they're actually trying to prove it, and that this trajectory try to show similar trend to basically the complexity of the idea. And then what they mention is that how they want to select is that they want to look at this cluster and they want to randomly select from each of the cluster. So what will happen is that you don't want to select only from one cluster, and the information within the cluster are kind of repetitive and don't give you more information. So this is also an idea related to multitask learning. When you are trying to do multitask learning, you need to consider multitask at the same time in order to avoid a catastrophic. So this is kind of aligned with that, but there's also a lot of challenges in here. I actually asked the author, and she mentioned that but this can be true. So they didn't actually know the answer. They mentioned that they need to explore it in more detail. And the question was, if you are, how do you know that some of these trajectories are actually, some of them are actually harder? And if something is harder, you want it to basically select more and more, because as we see, for example, annealing or so many other things, we don't want to treat all of the trajectory similar. So some of the trajectory might actually require more attention, but having this idea of selecting all of them with the same probability or randomness might bring some question for that. So that was all. Let's go quickly over the idea of sequential and time series. We see lots of people on the finance are actually very interested in this concept. From Bloomberg, we actually see that they categorize the large language models into commercial, proprietary, like for example GPT, GPT-4o, and then open weight, which is basically Llama and Mixtral, which you can fine tune, but you don't have customizable tokens. And then we have open source, which is fine-tuned from Microsoft, which you basically can also customize your token. So it is important to know what your open language is capable of. So data obviously need to be accurate, and it needs to be up to date. So very important thing about the time series or finance or stuff like that is actually it's very important that everything will need to be tied to a time. And what they mentioned was something about a factoid-based evaluation. So this is very important. They consider an LLM as a judge, and then they try to collect factoids. So again, instead of just comparing how is it relevant from the language model perspective, they want to see how much coverage of the factual information their generated result have. And so they generate some factors. So these are the facts that the specific response need to be included. And then here is the response from the LLM, and the LLM job will create something like a recall. So how many of this fact actually was mentioned inside it. So this is important, I believe, a good point to consider. And then we have a point in time evaluation, which basically means that you need to store the timestamp and knowledge. So real-world time series data contain many inputs. It has past observation, a prior known future inputs, so for example holiday dates, and then we have static features. And so only a subset of inputs are relevant, so not all of them are actually important, and inherently interpretability by design, non-post ad hoc, is desirable. So we really want to have something that shows this interpretability, because later on we can use it. And so we have TFT model, so temporal fusion transformer, and then we have end-to-end learning, time dependent on static interpretability, and then we have also tempo, so a prompt-based generative pre-trained transformer for time series forecasting. So the whole idea in here, in order to generate or consider this time series, is basically consider some base pattern. The base patterns includes non-periodic information, and then periodic information, and then random process. These are the three different things. And then you need to consider the composition of them. So you add them, multiply them, or consider sequential manner of them. And then you need to consider noise and anomality noise. So we have white noise, red noise, and then we have the different anomalies. So for example, it's flip, is speed higher down, or then it's cut off, or saturated. So these are the concepts. There are two papers, the FinBen, so a holistic financial benchmark for language models. So I think it's important to have this benchmark because lots of finance are actually trying not to provide the result for some reason, so they keep everything to themselves. This is not very good. And then we have RTOS, a recurrent architecture that allows efficient real-time recurrent learning. So this is also another important paper to consider for time series. Then we have very important agent and RAG. This is the most important one in terms of application. You see lots of basically companies, Salesforce, and like for example, lots of different service companies try to provide a result in here, like ServiceNow and so many others. So I think this is important to consider what they have to offer. We have Lamma Stack. This is actually something that was very recently released by Llama Group. I actually have a goal to go over it on the next video to provide you a basically deep dive into Llama Stack. I believe this is very important. And it will be considered something very similar to LangChain, but it have specifically designed for Llama family. Very, very cool agentic app. Let me know in the comment if you want me to go over it in more detail. And then we have different papers. These are also very important, like a RagChecker, a fine-grained framework for diagnosing retrieval augmentation. We have embodied agent interface, benchmarking element for embodied decision making, a Spider 2V, how far multi-modal agent from autonomous data science, and an API gen, automated pipeline for generative verification, and we have a function calling dataset, and then we have SwiGLU. CRAG, basically comprehensive RAG benchmark. I think this is a very good paper to consider, and on the effect of data scale on UI and control engine. Going on to the next one, the very old topic for language models, for any machine learning models, is optimization. And right now we see lots of it going towards the large language. So we only include the papers, but I definitely will suggest you to go over them. These are really important things and very simple hacks that you can do in order to make your fine tuning more stable. So you see lots of topic about Adam Optimizer, lazy algorithm, how algorithm will work. I also think this paper was nice, how to boost any loss function, and then the road less schedule by Meta, talking about learning scheduling, an optimal parallelism for boosting. So these are very great papers, and a Dagger exact gradient inversion for large language model. Definitely take a look at them, and I think these were the very most important. On number 8, we have RL, so reinforcement learning. I saw a lot more of offline arrays, so that is very important transition that we see. And I think the reason is right now why we don't see lots of RL in the industry was the fact that it requires to have an interaction with the real world. But offline actually try to solve that. So we try to completely just ignore that part and don't have any interaction. We have the offline data and we just want to work with that. And I think that's a canonical part of how RL can actually be used in practice in lots of applications, and try to consider the OOD and lots of the different complications that comes with it. So many papers in here. I'm not going to go over it, so you will see that the number of papers in RL is actually comparatively bigger compared to the other topics, and that was basically maybe because so many papers in RL are very cool. But specifically, I wanted to talk about the abstract reward processes. They're leveraging a state abstraction for consistent off-policy evaluation. So the idea in this paper was that how we can do a policy evaluation. So it can be in an online setting or offline setting, doesn't matter. But what is important is that I don't want to basically have my online RL, have my own policy to actually evaluate the exact policy that I have at this moment. And so what we need to do, you need to do it on behavior policy. So you need to have data that's very trained or very collected, sorry, for a different policy, and you want to know that how well this one is doing. And obviously there is a difference between the distribution of your behavior policy and your target policy. And for that reason, the very obvious idea would be basically the importance sampling, and they actually come on top of this idea of having importance sampling to convert the difference between the two probabilistic distribution. But the idea was very interesting because I saw that they mentioned, let's try to break it down exactly again, level of abstraction, and then the level of abstraction based on what the other mentioned is that it can go from the abstraction 0, which is no abstraction, and all the way to full abstraction, which means that having all of your states available. So if you consider something like this spectrum, this last of the spectrum would be having all of your states available, not a partially observable MDP, and in that case it's going to be a model-based RL. And then we have at the very beginning of this spectrum, which is nothing of abstraction, so it's going to be a model free. And then this was the first time that I see something in between. So there is something in between of a model free and model based. You can create some level of abstraction. For example, a model that have 10 number of different states, you can consider a subset of that and then try to generate the result that you're looking for. And based on that, you will basically create some cluster, and you say that, okay, so given this cluster, this is the trajectory that they will end up, and that's how you will also try to evaluate your policy on based on the how close is it to each cluster. And if you consider it on the lowest abstraction or completely model-free case, it would be a KNN or K-nearest neighbor. So you try to see that each data that you have right now, is it closest to which of these clusters, and based on that you're going to say, okay, if this is closest to this cluster, I would expect it to experience the same trajectory. So that was also an interesting topic. On number 9, I'm going to go over the computer vision task. We have a SAM1, again from Meta. The idea is that you have an image, you have an image encoder, and then you have some decoder. These are the ideas that are very important. You have an image encoder, you have prompt encoder, you have mask decoder, and then you basically generate some output. Then you have a SAM2, which is basically a combination of SAM1 plus memory components. So they just add some memory to basically remember what are the concepts that was included. You can definitely suggest you to go over segment anything paper, SAM1, SAM2, and then we have lots of other nice papers in here. Asynchronous perception, machine for efficient test time, on the comparison between multi-modal and single-modal contrastive learning, and rethinking a decoder for transformer-based semantic segmentation, and then talking about compression is all you need. And then we have there's so many papers on top of CLIP. So we have CLIP sale, domain generalization through CLIP via channel refinement, and VAT, a weighted average of test time adaptation of CLIP, and then we have unibench, or basically visual reasoning requires rethinking visual language beyond the scaling, and then calibrated self-rewarding vision language model. So these are also a very important topic. And finally, on number 10, we have the others category. I see a very prominent thing about knowledge distillation, and the reason is because we have lots of edge computation, or we require our model to perform better and better because it has been shown that the students actually can outperform the results of the teacher, which is actually sound kind of counterintuitive. But definitely take a look at some of the paper. You have a pre-training, train a smaller model to match Naice token probability of larger model, and then it can be on many different levels. So you can do it on token level, or you can do it on the basically the value of your, for example, neural network, and try to do feature matching. We have post-training synthetic data distillation. Use data from 4B to improve capability of lightweight models. So this is basically the data generation part. You generate some pseudo labels from your smaller model, from your bigger model, and try to train your smaller model on it. And then we have VLM agent generate their own memories, distilling experience into embodied programs of thought. And then DDK, very important paper, distilling domain knowledge for efficient large language model. And then this is something that I want to talk about. So understanding the gains from repeated self-distillation. The self-distillation is an interesting topic. Basically, the idea is that you can use a model to train from itself, but so as you can see, I can train a model, and then my teacher have the same size. So I'm not reducing the size, but I'm just going to use the first model to train the next model, and you will see that obviously you will get some improvement in the results. So it is a self-distillation. But if I do it another time, how many times I can still gain from this self-attention? So I think this is a very important concept of, and they very nicely actually talk about that and prove that what is the bound of the knowledge that you can get if you do multiple time, and then you can also do residual connection between your self layers, and you actually they compare the results of the amount of information that can be obtained. And another topic is distribution shift. So you see lots of the changes on the distribution. It can be as easy as epsilon balls, which basically you have the data, there is another uncertainty around it. That would be the very simplest distribution shift. Then you have adversarial example. This can happen a lot in driving autonomous driving situation. Then we have label shift, your output change, or you have covariance shift, or your input shift. You have domain shift. So, for example, for some reason a trend change or something change that results in distribution shift. You have shift over time, which can happen because of something that over time is resolved, or solution to a drug was found, or so on. And then subpopulation shift, and then outlier. So again, another important idea would be important weighting. And then there's idea of include models are cheaper for classical ML problem. LLMs are more data efficient in terms of needing less annotation to achieve the same performance. So kind of the idea of future learning. So knowledge distillation is the best of two worlds. So gold, we get the gold data to train on LLM, and then distill the silver data, or the data that we get from the large neural to train a BERT. So this is the distillation, and then there is talk about out of distribution detection with diversification. They have provably show that how they can provide diversification and changing the training data to reduce simplicity and bias improved in distribution generation. So these are other very nice papers that you can definitely take a look at. And there you have it, guys. We went over 10 different categories and spotlights and talks that have been done in the NeurIPS conference this year, 2024, in Vancouver. And we talked about some of the concepts. And if you want to see the full list of the papers, make sure to look at the description of the video. I put the list of the papers there, so you can go and look at them on your own. If you enjoyed this type of video, make sure to like it, and more importantly, subscribe to the channel so you get more videos like this. If you want to learn more information and you are technical, you can watch this video that I talk about autonomous driving and how I design a perception model and an end-to-end approach to train basically car simulator. And you can watch this video if you are an RL person and you want to see how to handle an sparse reward in a situation that you want to train a model that have a sparse situation. And if you are not technical and you want to basically come into this AI agent because you see that it's coming everywhere, you can watch this video that I talk about the road that you need to take, what are the steps required for you to get your ball going. Thanks for watching, and see you until the next one.